On Wednesday, we were talking about reciprocal functions. We already know SOHCAHTOA, sine, cosine, and tangent, and then we talked about the reciprocal functions. So as a reminder, secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So we did number 1, so we're going to skip down to number 2. If secant theta equals 25 over 7, so in your mind, you're thinking, okay, secant theta, that's the reciprocal of cosine. And I know cosine is adjacent over hypotenuse, so secant must be hypotenuse over adjacent, the reciprocal. Next, you're going to draw a triangle, a right triangle, right angle, our theta. So our hypotenuse is 25, and the side adjacent or next to is 7. So we don't know what the missing side is, so we should use the Pythagorean theorem to find out what the missing side is. So a squared plus b squared equals c squared. 7 squared plus x squared equals 25 squared. 7 squared is 49 plus x squared equals 25 squared is 625. Okay. When you subtract 49 and take the square root, you'll get that x is equal to 24. So that's our missing side here. Now we can fill in all of the questions. So first it wants us to find cosine theta, which is going to be the adjacent over the hypotenuse. So 7 over 25. Cosecant theta, which is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite, which if we look at our triangle, the hypotenuse is 25 and the opposite side is 24. And then tangent, TOA, opposite over adjacent. So 24 over 7. Okay. Number 3, they tell us that the cotangent is 15 over 8. All right, so you think that's the reciprocal of tangent. So that means tangent theta must be 8 over 15. Okay, which is the opposite over the adjacent. So this is the adjacent over the opposite. So draw a triangle. You have your right angle. We have our theta. The adjacent is 15. And the opposite is 8. So go ahead, find out what the hypotenuse is using a squared plus b squared equals c squared. Oh, not x squared, x. All right, you should get that x is equal to 17 when you solve this. The hypotenuse is 17. So then let's find sine, cosine, and cosecant. So sine is opposite over hypotenuse, which will equal 8 over 17. Cosine is adjacent over hypotenuse, so 15 over 17. And cosecant is the reciprocal of sine. So we already know sine, so let's flip that fraction and get 17 over 8. Okay, so now using that triangle that we just have above in exercise 3, let's find the value of sine theta and cosecant theta. So these are the reciprocal functions. Let's find out what the value is. All right, so sine of theta, I'll just redraw the triangle here. Okay, sine theta is 8 over 17. and cosecant theta is 17 over 8. When you multiply those, okay, we could cross simplify. The 8 and the 8 cancel out, the 17 and the 17 cancel out, and we're left with 1. Okay. Let's see what happens when we find the value of the cosine of theta and its reciprocal secant theta. So using that triangle above, cosine theta is 15 over 17. And if I multiply that by the reciprocal or secant theta, it would be 17 over 15. And again, the 15s cancel out and the 17s cancel out. So we are just left with 1. Okay. It's not a coincidence. When you multiply a function by its reciprocal, you'll get 1 because they are multiplicative inverses of each other. All right. Flip the page over. We're going to do the next notes now. So now we're going to solve trig equations using those reciprocal functions that we just learned. So remember, secant theta is the same as 1 over cosine theta. Cosecant theta is 1 over sine theta. And cotangent theta is 1 over tangent theta. Okay, these are called the reciprocal functions. All right, so we've solved linear trig functions, quadratic trig functions, and now these are just some more trig equations with these reciprocal functions. All right, so we always look at the directions. It says solve for theta. They tell us our domain, so from 0 to 360 degrees. If necessary, round to the nearest degree. All right, let's do this first one here. It says 2 sine theta plus 1 equals cosecant theta. All right, so when we get these, we actually want it to be in one trig function. So the first thing we're going to do is rewrite the reciprocal function in terms of sine. Okay, so what that will look like is 2 sine theta, that won't change, plus 1 equals, okay, cosecant is the same as 1 over sine theta. Okay, now I need to solve for theta here. So one approach that you can do here is you can cross multiply, or you can multiply both sides by sine, whatever you like to do. So if you cross multiply, which I think a lot of you like to do, okay, you'll get 2 sine squared theta plus sine theta equals 1. Okay, and then we need to subtract the 1 over. So we'll have 2 sine squared theta plus sine theta minus 1 equals 0. And then we need to factor this. So sum and product, two numbers that add to 1 and multiply to -2. Okay, you should get +2 and -1. We're going to write this out using 4 terms. So we have 2 sine squared theta plus 2 sine theta minus sine theta minus 1 equals 0. Factor by grouping now. Group the first two together, group the second two together. The GCF of the first grouping is 2 sine theta. Okay, you're left with sine theta plus 1. And then the GCF of the second grouping here is going to be a -1. And you're left with sine theta plus 1. Okay, now we are going to have our factors. Our factors are going to be 2 sine theta minus 1 and sine theta plus 1. Okay, make your t-chart. Two sine theta minus 1 equals 0. Add 1 and divide by 2. You'll get that sine theta equals 1/2. Over here, we'll have that sine theta equals -1. Okay, and then you need to figure out the reference angles and then all of the angles between 0 and 360 where sine theta equals 1/2. So the reference angle for sine theta equals 1/2 is going to be 30 degrees. Okay, you're going to draw your quadrants. Okay, sine is positive in the first and the second quadrant. All right, so I'm just going to draw up here so I don't run out of space. All right, so in the first quadrant, theta is equal to 30 because it's always the reference angle. And in the second quadrant, theta is equal to 150. Okay, so we have theta is equal to 30 and 150 so far. And then for -1, we know this is an angle on the axes here. So I like to label them all, as you know. 0, 1, -1, 0, and 0, -1. Okay, I want to know when sine theta is equal to -1. Well, sine is the y value, so it's equal to -1 at 270. All right, so putting those all together, theta is equal to 30, 150, and 270. Okay, let's do number 2. All right, so number 2 says 2 cosine theta equals secant theta. So again, you want them in terms of the same trig function. So I'm going to rewrite secant theta as 1 over cosine theta. Okay. And now I'm going to solve for theta. So I'm going to cross multiply. So I have 2 cosine squared theta equals 1. Okay. Then here to solve, I just need to divide by 2. Cosine squared theta equals 1/2. Okay. And then I need to take the square root. All right. Remember, whenever you take the square root, you need your plus and your minus. The square root of 1 is 1, and the square root of 2, we're just going to leave as the square root of 2 for now. Okay, remember, we're not allowed to have a radical in our denominators, so we're going to rationalize this fraction here. So what that means we're going to do is multiply by the square root of 2 over the square root of 2. That will get rid of the radical in the denominator. So cosine theta is equal to the plus and minus the square root of 2 over 2. Okay, so then you think about what is the reference angle for when cosine is equal to the square root of 2 over 2. Well, the reference angle is equal to 45 degrees. Now I want to know when it's positive and negative. So that's going to cover all of my quadrants. Okay, because in the first quadrant, it's positive. Second quadrant, it's negative. Third quadrant, it's negative. Fourth quadrant, it's positive. So in all four quadrants, I need to find out the angles when the reference angle is 45. And that's what theta will be. So you could draw a set of axes. Okay. First quadrant, nice and easy. It's always the reference angle. We love that. All right. So I'll start a list over here. Theta equals 45 degrees. Okay. In the second quadrant, okay, 180 minus 45 is 135 degrees. In the third quadrant, 180 plus 45 degrees, you'll end up at 225. And in the fourth quadrant, if this is 360 minus 45, you'll be at 315. All right, so these problems are really just adding that first step in the beginning. And then the rest of it is what we've been practicing for a few days now. All right, so what I'm going to have you do for your homework is going to be, or classwork, the rest of class right now, is going to be number 3. All right. Number 4, I actually need to change the problem. So number 4, I want you to have secant squared theta minus secant theta minus 2 equals 0. All right. Little trick for number 4 here. Since they're already in secant, don't change it. Solve this using secant. And then at the end, make it into cosine. But since it's both in secant here, you don't need to rewrite it in terms of cosine. Just leave it as secant until the end. Number 4. Number 5, you don't have to do at all. And then I want you to do number 6. So number 6, again, it's in cosecant. So leave it in cosecant all the way through until you find out what the cosecant theta is equal to, and then change it to sine. All right, so that is what you'll be doing now.